Welcome to lesson 5. Lesson 5 is discrete random variables. So this is sort of a stepping stone into probability models. And in this case, one that's generally a little easier to understand because discrete means it's something that we can count. So there's only a finite specific set of possible outcomes, and each of those outcomes has an associated probability with it. So we can take those outcomes and their associated probabilities, and we can create these probability tables. And then we can run some statistics, sort of saying what would we expect to happen on average, and what would the spread of the random variable be. So if you came from Math 115, some of these ideas will be familiar. We did cover binomial distribution in Math 115, which is the biggest idea in this section is the binomial distribution. We use the binomial distribution primarily when we are modeling proportions. So binomial means there's two outcomes, a set number of trials, and we're counting how many of those trials are successes. So for example, I could roll a dice 10 times, and I'm either going to roll a 6 or I'll roll something other than a 6. So out of the 10 times, how many of them were 6s, right? It's possible I could roll 0 6s. It's possible I could roll 10 6s, but that's very, very unlikely. So the binomial distribution is used to model proportions because somebody is usually either going to be in the success or the failure group. And then we're looking at the percentage of people that are in one or the other group, just as one example. So the binomial distribution will be used in inferential statistics a little bit. And there's some resources down here to find the mean and standard deviation on your 84, the expected value on the 84 and an Excel, and the binomial cumulative distribution on the TI-84. Note, there is another binomial probability calculator that you can use if you don't use 83 or 84. So you just need to enter the probability of success. So let's just say I had a 56% probability of success and I'm doing 30 trials. The number of successes I could say is something like 8. So this is now the probability that X is equal to 8. Probability X is less than 8, less than or equal to 8, more than 8, more than or equal to 8. If you want to use this resource, just make sure you tell me P, N, X, and then which of these values did you use? So if you say Px less than 8, right, this symbol with that value and these numbers, now I could recreate it and potentially look for mistakes if you're using this calculator. If you have any questions, as always, please let me know. See you in lesson 6.